Okay, so my name is Eric Florenzano, and my talk is about challenges that I've faced in A/B testing mobile native apps. So first of all, why am I interested in this? Last year, I started a company, and the goal was to make a bunch of iOS apps. And we were going to try a bunch of different things and figure out what worked. But after the very first app that we built, we sort of realized that the tools that we wanted weren't quite there yet. So we ended up building a bunch of tools for doing things like A/B testing and iterating fast. Twitter ended up acquiring our IP, but we were able to open source everything that we built for A/B testing and for rapid iteration. So you can check that out at github.com/clutchio. But before I kind of get started here, I want to get a show of hands. How many of you guys here do like web stuff? Like raise your hands. Okay, so pretty much everybody here is doing some sort of web stuff. And keep your hand up if you're doing A/B testing on the web, or if you've done that kind of stuff before. Okay, so actually not very many people. How many people do iOS or Android apps? Okay, a couple people. And how many of you guys do A/B testing on iOS or Android? Okay, so literally nobody. Okay. So we're kind of breaking new ground here in terms of what's possible to do on some of these native platforms like iOS and Android. So since there were a lot of you guys who haven't really done a whole lot of A/B testing stuff, I want to really quickly just go over what I mean when I say A/B testing. So at the very basic level, what A/B testing is you show different users of your application slightly different variations of the app. And then you track those users as they use your application, and you analyze their actions, and you figure out which users are actually performing the best, or doing the things that you want to do. They understand your app the best, or they're registering more, whatever you want them to do. So a couple of like sort of real world examples. Everybody uses the example of changing the button color from red to blue or whatever, and that's really lame. So I try to come up with a couple of more realistic examples of things that you could A/B test. One thing that's really common for people to do is just test different wording. Something like register, sign up, create account. Those are all slightly different sort of concepts, and sometimes users can understand one over the other more easily. Another example that I've seen done is on a mobile website. There were a lot of people who were signing up and were dropping off on the registration step. So one of the things that was in that registration form was an email field. And so one of the theories was, well, if people are signing up on this mobile website, they're probably on their phone. Maybe swapping the email field for a phone number will get more people to sign up because it's sort of more in context. And then we could verify that by text message. So that's something that you could test using an A/B test. Another example would be as users are signing up, sometimes if you add more text that's explaining what your service does, it can actually help people to get into the service easier, but sometimes it can actually distract people and cause them to sort of go away into the woods and not register. So the question is, does adding more explanatory material, does that help signups or does that hurt it? So those are the kinds of things that you could test using A/B testing and see whether they improve. So basically, how do A/B tests work on the web today? Right now, it's basically very simple. The back end determines what bucket the user is in, whether they're in the control bucket or in some sort of experiment. And then somehow, either through templates, changes the display, or passing that through JavaScript, has JavaScript change the display. It's very straightforward, very simple. And this is an example of how that might actually look in like something like Django, where you have some sort of a tag where you say, okay, for this user, which bucket are they in for the phone sign up? Are we going to show them the telephone number version, which would be the top block, or are we going to show them the email version, which would be the bottom block? And then the system can make that decision, record it, and show the user the correct version. So it's very straightforward when you're doing this on the web. You can imagine an app that would do this very simply. And so then when you translate that to mobile, this is like an example of more of an Objective-C style of writing this. And it's very straightforward as well. So if, and then there's an A/B function, you pass in a user, you give it some sort of test name, and then it decides which block they go in. And that seems all very straightforward. Unfortunately, though, it doesn't quite map one-to-one that way. The questions that you have to ask yourself are, how would that even work on mobile? What can the latency be on that call? Can it be 100 milliseconds? Can it be 500? Can it be a second? Can it talk to a database somewhere on the server? What happens if you're actually offline and you can't access the server somewhere? So all of a sudden, this seemingly easy concept of trying to figure out which A/B test or which bucket to put the user in, all of a sudden it gets very difficult. So how do you deal with this on the mobile environment when you could be offline? Well, the solution is to, like when the user opens up the application for the first time or when they foreground the application, you can actually download a manifest file that contains all of the running A/B tests for the entire application. And the percentages of how many people should be in bucket A, how many people should be in bucket B, and how many people should be in control. And then the client actually can be smart enough. You have to build this into your A/B testing library, but the client can be smart enough to look at that manifest file, determine for itself whether which bucket the user should be in, and make that decision immediately and offline. And that way, all of a sudden, you can make that call. So then that presents you a problem, because if you're downloading this manifest file when the application launches, there's going to be a case, there's going to be a pretty large edge case where the very first time you launch the application, that's not going to have the manifest file, and you might want to A/B test what's on that very first screen. In fact, most of the most important things that you're going to want to test are going to be on that very first screen, which is probably going to be a sign-up page or some sort of call to action, something that you really want people to click on or do. So one of the answers that, like the way that we did this when we were building our solution, was that we actually enabled an option where you could drag the manifest file into the application, bundle it with it, so that on the very first launch, there was an actual manifest file included. Unfortunately, there are some downsides to it, which is A, you have to always be constantly trying to use the downloaded manifest file and then fall back to the included manifest file, which can add some complexity to your code. And the other thing is it adds another step to your build process where you're having to actually generate and then bundle that manifest file with the application, which is can be a bummer. But that is one way that you can solve that problem. So basically, once you've got all these tests running, you've got these manifest files downloading, you're making these decisions, you're putting people in buckets, you're running these different experiments, the question then becomes, basically, are the users doing what we want them to do, or are the users not doing what we want them to do? How can we track these goals? How can we figure out whether a test is successful or whether it's a failure? How can we determine, basically, if it's working? And so, the best thing is if you have a really good understanding of your user, if you have really detailed analytics, if you have a really great understanding, you can actually track all kinds of metrics. But the bare minimum thing you absolutely need to have in terms of figuring out whether this test is successful is to have a Boolean sort of goal reached. So for every test, maybe you'll have a user who goes through a flow. You want to have some sort of end goal that they can reach. So for example, on the front end, you might have a goal reached where they actually fill out all the forms of a sign-up page and they hit submit and it all validates and goes through. That you could tag them as, okay, they've goal reached, they've successfully registered. But you actually need to have the ability to tag this on the front end and the back end, because there's a lot of cases where you're actually going to want to tag them as reaching their goal asynchronously, not inside the app. For example, sometimes you want to send them an email and not tag them as having reached their goal until they actually click through, say that they've verified their email address, and then you actually want to tag them as having completed the goal. Another example would be like verifying a text via a text message. That's not something that's actually happening within the app. It's happening out of band. So you need to be able to tag that a user has reached a goal in the back end as well. So again, we go back to the same sort of question of what happens when the phone is offline. The sort of naive way of implementing this goal reached function that I was talking about here is something like, well, every time you call this function, it does a REST call pings a server somewhere and notifies the server that the goal was reached. But unfortunately, there's a lot of times when the phones or the mobile application or the mobile device is going to be offline. For example, if it's an iPod Touch, they're on Wi-Fi and they're not actually near an access point. So the way that you deal with this is that you actually just store it on a local database. All of these phones have basically SQLite storage, so you can actually create a local database and track all of these goals in that database as they're going through them. And then what you actually have to do then, once you're storing this in this database, is you have to periodically upload like in a batch, all of the current running tests and how they're performing. And a really good time and place to do this is when they actually take the app and put it in the background. So whether they hit the home button or whether they turn off their phone, you actually have a few seconds to do a couple of more things in the application. So it's a really good time to try and upload some of that analytic data. Unfortunately, you only have a little bit of time to upload that data, especially on iOS. So sometimes actually about half the time you'll realize that the data doesn't actually fully get uploaded. So you have to make sure that you're uploading it on launch as well, which leads to some complications, which is that your backend sometimes can receive data twice. And so unfortunately, you have a couple of ways to deal with this, and neither of them are particularly good. One way that you can do is for every row of data that you get, you can query before you actually write the new row to the database, which is not good from a performance point of view, but it's a sort of a simple and good way to do it if you don't have a whole lot of traffic. The other way you can do it is you can actually just have it be completely write-only, append-only, and then have a process that goes through and dedupes before you insert it into the database, before you do your ETL. So that's something that can be really, really useful. But it's important to be aware that this can happen, though, especially since you're logging all of this into a database and batch uploading it. Your hot set of data can be really wide. You could be receiving data that actually was recorded a month ago, or 2 months ago, or 6 months ago. Sometimes people they use your application and then they'll shut it down and they won't open it back up for a few months. So you have to be very careful when you're designing your backend, such that getting old data isn't going to like completely screw you performance-wise. And so one of the ways that you can actually do that is just by having a cutoff date and saying, okay, anything older than a week old, just discard it. Don't even log it. That's one way that a lot of people have sort of dealt with this issue. And I think that's probably reasonable, especially if you've already kind of dealt with all of the A/B testing results. If it's more than a week or two old, you might not even care anymore. So there's another caveat, something to kind of talk about in terms of if you just implement things in the sort of the naive way, you'll have a user go into a different bucket each time. But it's actually really important for a user consistency point of view to have the same user be in the same bucket for the duration of their session. So you can imagine how, in the example I was using before, where you're choosing between a phone number and an email field. Well, imagine they're shown this screen, they're typing in their email, and then they decide they want to go check their email or something like that. They open your application back up, and all of a sudden it swaps out and it's showing them a phone number. It could be a really jarring experience, and it could be really confusing for the user. So the best practice here is to actually make sure that you're tagging that user to a specific bucket and then only showing them that specific test again and not putting them in a different bucket from session to session. So that sort of begs the question, how long is a session? And this is sort of there's no real best practices here. At the beginning, like when I first started doing this stuff, I put people in buckets forever, and they never went into another bucket. They were always in that same bucket. But over time, I've sort of changed my mind a little bit in terms of thinking, and now my thinking on this matter is that a good heuristic is to put them in the same bucket forever, and then as soon as they update the app, it sort of wipes clean all the buckets. And then the next time they launch the new updated version of the app, they can be in a different test bucket, because people are kind of used to seeing changes when they update their app. It's not that jarring. So I think that's actually a pretty good heuristic. And the benefit of doing that, of knocking them out of the bucket, is you actually have more sort of a wider range of people to choose from for tests. Whereas if you put people in one bucket forever, you kind of have a dwindling amount of users that can actually be in a new bucket. So I want to kind of back up and talk about, okay, all the things that I've talked about, these are kind of what I consider to be the minimum requirements for a A/B testing solution for mobile apps. So you have to be able to download the manifest file of all the different tests that are running up front. You need to be able to make that weighted random decision offline and make that instantly on the phone in the client. You need to be able to track all the goals and all the progress of all the goals offline in a local database, and make sure that for each A/B test, you're actually pegging that user to that same bucket every single time, and then periodically uploading all your progress. So that's kind of like, it's a lot there, but this is what I consider to be sort of the minimum requirements for a good mobile A/B testing solution. So the next problem that you kind of have, and this is a big one, and this is the one that sort of confounded me for the longest, and I've had the most trouble with, which is when you're dealing with the App Store, especially on iOS. Android is a little bit better because they have a little bit looser safeguards there. But on iOS, it can take a really long time between when you've developed your application and when it actually hits the store for your users to use. And that not only applies for new applications as they're hitting the store, but for updates to your application. So that can be very, very frustrating, especially when you're trying to move fast and A/B test lots of different things and really sort of get a lot of data. So the question is, can we do anything to improve this cycle and make it faster? And the solution, the best thing that I've come up with for A/B tests specifically is that we invented something called, well, I don't know if we invented it, but we came up with something called parameterized tests, or I think we called them data-driven tests, which is just a slight change in the way that you think about A/B testing, but it results in sort of a richer amount of things that you can do in between release cycles, which is, instead of all of the examples I've given up till now have an if, they're in some bucket, then do some block of stuff, otherwise do some other block of stuff. But the change here is that instead of having two different code blocks, you have one code block that's passed some amount of data, and then you extract sort of the information that you care about from that data block, from that data that's passed in, and you can actually create n number of tests from that data. You can change that on the server, it gets updated in the manifest file, and you can basically create new tests in between release cycles. The downside is you really do need to think ahead. It's not going to allow you to create completely new A/B tests, but it'll allow you to create new variations on your existing A/B tests, which is really cool. So here's an example of how that might work on iOS applications. So you'd say, okay, I've got this test, it's called login, and you see that you're passed, this is kind of like a code block in Objective-C, and you're passed some data in there from the server. And based on this data, you're extracting the title key from that data and setting the button's title to that key. So for example, you could imagine you have, this is kind of going back to the example I was talking about earlier, where you have sign up, login, sign up, register, create account, like there's all these different ideas. If you find out that people understand the word register better, then you can say, okay, now that I know that people understand register, let's try register free, register now, register instantly. We can try all these different variations on the one that's already won. And then once you kind of find a winner, you can crank that all the way to 100% so that all future users just get the best version. So you can imagine you can do this with things like positioning. You can do this with things. It's not just copy that you can do. You can do anything you can stuff in basically a data dictionary. You can extract that out and use that for A/B testing. So again, I want to stress that this is actually, even though it looks like this is being passed data from the server, that decision still needs to be made instantly, offline, on the client side, and it actually can't talk to the server to actually make that information happen because it needs to be able to display immediately. So the way that you have to deal with it is you have to put all of the possible data into the manifest file that you're downloading. So you can't exactly put bitmap data or do anything super data intensive in this kind of thing. So that's just something to keep in mind if you're going to do this technique. So now you've got data collecting, you've got all these results going to your server, but the problem is you need to interpret it somehow. And this can actually be harder than it seems. But basically, when it comes down to it, when you're looking at your A/B test results, there's lots of different things you can think about. There's lots of different things you can care about. But when I'm looking at tests, I care about basically two things. A, which variation is winning, and B, how confident am I that that variation is winning? So let's kind of tackle both of these problems in part. Which variation is winning? This is actually pretty simple to do. You basically, for each variation, you say how many people have seen this, and of those people who have seen it, how many people have reached the goal for that variation. So for a register button, or for a sign-up page, it could be how many people actually clicked that register button. And you just basically get a ratio at the end of that, and you say, okay, 80% of the people who have seen this variation are doing what we want them to do, whereas in the control experiment, 60% of people are doing it. So we can say that theoretically, this new variation is winning. We're doing something better. But the ratio is not the only thing to look at because, unfortunately, unless you've got statistical sort of analysis on your side, you might not actually be confident in those results. So unfortunately, I have to say, I basically failed statistics in college, so I don't really know what I'm talking about here. But thankfully, there are people smarter than I am who have put libraries out there and can help you. But basically, my understanding, and correct me if I'm wrong, please, is that you basically have to choose a p-value, and that will tell you, or the higher the value you choose there, if you choose like 0.25 or 0.3 or something, actually the less data you need, but the problem is that the data is going to be a little bit less accurate. So basically, you want to choose a lower p-value if you want to have more accurate results. And then what you can do is you can compute a confidence interval that's going to give you basically the plus or minus of how confident you are in this and the percentage-wise. And then doing a little bit of research, I found that the agresti-cool interval is a very good choice, so I highly recommend it. But anyway, there's a really great open source library called ABBA, and it's put out by the Thumbtack crew, and it's actually really great. So what this will give you is, here's kind of an example, and you can go to thumbtack.com/lab/ABBA, and it's a JavaScript thing that will let you basically put in some of these things. So basically the idea here is you put in a baseline and you say, okay, how many successes and how many trials for the baseline? And then you say, okay, for each variation that you have, and you can have a B, C, D, you can have as many variations as you want, you say, okay, these are how many people I've sent through this variation, and this is how many people have actually reached the goal. That's how many successes there are. And then as you can see down at the bottom, it shows you, okay, now for each individual variation, what's our confidence interval? You can see that this thing, it's a pretty wide confidence interval, but it's very indicative that it's a better result than the previous thing. So that's basically a really good solution for being able to visualize and interpret your results. And if you know a lot more about statistics, you can really dive in and figure out more about that. But this is kind of a bare minimum. So that's kind of it. If you've got any questions, you can, or if you want to check out some of the stuff that we've open sourced, it's on github.com/clutch.io. And I think if you go to clutchio.github.com, we have a little bit of a landing page there that you can check out. And that includes iOS libraries, Android libraries, server stuff, of a lot of the things that I've talked about here. And it's open source, so we're accepting all kinds of contributions and things like that. You can also follow me on Twitter, EricFlow. I work there now, so I don't know. That's kind of cool. So yeah, any questions? Yeah.
Have you tried using it for UI? It's not just copy, but UI stuff?
Yeah, definitely. One of the major tests that I've done is actually swapping like positions of things. I set up a test one time where there were I think 4 different variations. One where like the user picture was on the left, one where the user picture was on the right, and a couple of different variations thereof. And it was surprising which one, like the one with the user picture on the left